basically it made 2170, but only at 9,500 RPM. And they were going to 11 or 11.5 that day. And it was already at 110 PSI, I think.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by JT Oliver from JTO Power. JT is breaking the internet of late with some of his outstanding fabrication work, specifically on a Mazworx and Shane T combo compound triple turbocharged SR20 drag engine. Now, I know that is an absolute mouthful. We'll chuck a link to some photos of this particular car because words don't do it justice. But suffice to say, JT has been instrumental in the build of this car from a basically bare chassis. It was absolutely nothing. He has built a complete tube frame chassis as well as all of the fabrication for what is a really intricate exhaust manifolding installation. Not a lot of room to fit 3 turbochargers, intercoolers, wastegates, etc. in the front of even a tube framed drag car. This conversation with JT goes deep into the world of fabrication. We learn what it takes to start and run a shop. We learn about 3D modeling and the importance of 3D modeling in what JT does today. We'll also learn about the advances in 3D printing of metals and how he's managed to use that to his advantage when designing and building a one-off plenum for this particular SR20 drag engine. We'll also learn about the different materials used in roll cage and tube frame construction and some of the pros and cons, particularly around the use of 4340 chromoly and how that needs to be treated to ensure that it is safe and reliable and doesn't become brittle near to the welds. On top of this, JT also gives us some of his pro tips on how to get the best quality welds. I'm talking here around fitment and cleanliness. So if you are starting your journey as a TIG welder, there's some absolute gold in this interview. Before we get into our interview, though, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune on both factory and aftermarket engine management systems. We cover performance motorsport wiring. We also cover fabrication, and we cover race car driver education, race car setup, and data analysis. Relevant to today's topic, because we obviously are diving deep into fabrication, are our fabrication courses. This includes our Motorsport Fabrication Fundamentals course, which, as its name implies, teaches you some of the fundamentals that apply to fabrication in a motorsport environment. Now, I know that a lot of enthusiasts tend to think that fabricating their own parts is a little bit beyond their skill set, but the reality is that if you understand the techniques, some of which are relatively basic, and you understand the tools that you're going to need and how to use them to your advantage, you can actually do a lot with a relatively minor outlay, and it's really satisfying to be able to make your own parts exactly how you envisage them. On top of this, though, really when it comes to motorsport fabrication, this goes hand in hand with welding, and the go-to option for welding in a motorsport environment is typically TIG welding. Here we've got our practical TIG welding course. TIG welding is one of those skills that requires a lot of practice, but it also requires a deep understanding of the correct setup of your TIG welder. Getting this wrong will be a guaranteed result of poor welds and a lot of frustration. So our TIG welding course helps you fast track your progress here. We'll teach you how to weld just about every type of material you'll come across in motorsport, including more exotic materials like aluminium and titanium and chromoly. We've got a quick start guide that will give you the correct settings for your TIG welder for these different materials, and then we've got a step-by-step process that you can follow to ensure that you get the best possible results irrespective of the type of material you're welding. We also have a TIG purchases guide, so if you are in the market for a TIG welder, we'll help you narrow down exactly what you need to get the best bang for your dollar. Our course also includes a library of worked examples where you can watch our step-by-step process being applied in the fabrication and welding of different components. And in that library at the moment, we have both an alloy and a stainless worked example. So those are probably the most common materials you're going to come across, and you'll learn the different skills needed for each of those. Now, I'll put a link in the show notes for both of those courses, and as a podcast listener, you can use the coupon code podcast75. That'll get you $75 off the purchase of your first HPA course. All right, let's get into our interview with JT now. All right, JT, welcome to the podcast. Thanks for joining us today. As usual, we always like to start out by getting a little bit of background on our guests, and I want to start by figuring out how you got involved in cars and the automotive scene in the first place.
Sure. Thanks for having me. I guess I've gone to cars like most people in high school. So got my first car, started messing with friends. It just kind of usually goes on from there. Ended up working at a machine shop for a while, just sweeping floors and pushing buttons on CNC machines. From there, I went and worked for Injuku for a little bit, building drift cars in like 06, I think it was, 07 maybe. And after that, I went back to the machine shop, ran a night shift for a while by myself, which is boring, doing production, and then ended up building high-end staircases for a while.
It's a bit of a different path from the automotive industry.
Yeah, it was a little different, but really fun, neat. Got to learn some good fabrication skills because we were building spiral staircases on penthouses and on Park Ave and 5th in New York, and 180-foot yachts.
Multi-million-dollar stuff.
Yeah. Huge condos. One of the yacht projects, we built a whole set of handrails out of solid nickel. Yeah, it was pure solid nickel, and then it got scrapped because they didn't like the look compared to the nickel plating, which was originally suggested. So let's see. And then after building stairs for a while, my friend Kevin Van Cleve, who was at Injuku, who is KSV Looms, he was in Grand Am and just said, you want to come and build some Mini Coopers on a team for a while. So I jumped off from stairs and went and did Grand Am, or what's now IMSA, road race cars for about like 5 years.
Okay. Let's dive back into a couple of these elements. So just talking about getting involved in cars in the first place, and as you mentioned, sort of probably like most people listening to this podcast sort of happens when you're a bit younger. Just from what I've seen on your Instagram, it seems like you've been drawn more to the JDM side of things rather than the USDM vehicles. Is that a fair take on it? And if so, what sort of drew you to those vehicles? Was it the drifting scene?
Yeah, I originally had, my first car was a 91 Civic hatchback. And then after that, got a 92 Civic hatchback. And eventually did a B16 swap and had that for a while, and then drifting got really cool and I wanted a rear wheel drive car, so got S13 and did an SR swap and did a whole bunch of drifting for a while. And then I don't know what really drew me to it. I guess I like the look of them. They're cool, but it was just kind of a little bit of that underdog world, I guess, not a V8 maybe. I don't know. Could do more with less, maybe.
It's as good a reason as any.
Stupidly assuming, but time now, it's proved out that it's pretty cool.
Yeah.
4 cylinders definitely do some stuff.
All right, so it sounds like you developed some mechanical skills as well along the way. I'm interested in sort of learning more about the fabrication side of your background. So how did you get drawn into that, and was this all self-taught? Have you got any formal qualifications in fabrication?
All quite self-taught. I've always tinkered, I guess. Like I was in like woodshop class, I skateboarded a bunch, so always building ramps or making things. So to get into fabrication, I guess it was a bit like out of necessity. I remember like when I did my B series swap, I eventually could see like cold air boxes, like kind of like how the ARC ones are and stuff. And I got like, what is it, kind of like the foam insulation, like the thin foam insulation and like aluminum tape. And I built like a little box in my garage, like before I had like anything, and probably didn't last very long. But from there, probably being in the machine shop was a lot. That's where I got into machining. I didn't have any welding or like sheet metal skills at that time, but I ended up machining some parts. Someone needed a bushing. I'd end up making something on the lathe between run times. If I got all the machines running, I'd have 2 minutes to jump on the lathe and turn as much as I can before I got to run over and change parts again. So yeah, I guess it'd be out of necessity.
Okay.
From there, it just kept progressing. Ended up buying a welder after I was at Injuku. I got to use the TIG welder once, and I was like, oh, all right, I'm
Sold.
gonna go get one. Yeah, just went and bought one. It's kind of the only way you're gonna learn is practice. So I just kind of jumped in and bought one.
I think initially, the sort of the usual path for an enthusiast who's wanting to do some basic fabrication work or modifications to their car, normally the easy path is to start with MIG welding. But I think while TIG is definitely is a lot more to it, there's a steeper learning curve once you've actually mastered that. The quality of the welding, the flexibility, particularly being able to weld ferrous and non-ferrous materials, it's a no-brainer, right?
Yeah, I still don't like MIG welding. I don't think I'm very good at it. I've done a fair bit of it, but if I had my choice, I'd TIG weld all day long. I mean, technically, the first welding I did was with a stick welder. I tacked together some intercooler piping for my S13 because I couldn't find anybody who would actually after the point, I couldn't get anybody to weld it for a while. I tacked it up and I figured that'd be the hard part, or, that'd make it easy for anybody else. Like, just hand it to him and be like, here, can you weld this? And it took forever until I found somebody to do it. But yeah, I mean, it was initially stick weld tacked together piping,
nice.
Steel piping for my S13.
Okay.
So
as long as it gets the job done. Talking about the machine shop experience, obviously that's played into some of what we're going to talk about with your business as well. Were you there essentially just managing the machines? Obviously, you've just mentioned you could obviously use a lathe. So how did that sort of knowledge come about? Were you being taught by other people in that business, or is it again self-taught and just picking up from doing it?
So I worked for a paintball gun or accessory manufacturing company at their, I guess, main warehouse doing like packaging, shipping. We did some laser engraving there. And they had a lathe and a mill there, like two manual ones, just for odd little modifications for other vendor parts maybe. So I got to play on the lathe there for a good bit. And then when I moved to Orlando, the machine shop that was manufacturing all the parts, they were here. So I kind of got just shoved in there because I already worked there, and they were like, here, you need somebody to sweep. It was kind of under the paintball company that owned the machines in the shop. It was run by somebody else though. So I got shoved in there as somebody just help and sweep and push buttons and do whatever. And once I was in there, they liked me enough to start teaching me a couple things. So I'd have to do some second op lathe work where I got to stand there and turn a piercing point on some pins for 1,000 of them or something like that. I'd sit there and grind these mandrels, or I guess it's like a mandrel that would get pulled through barrels. And so I had a lot of mundane tasks that were very repetitive, but I got comfortable enough on the machines where I could then start to learn my own things, start making some of my own little parts, little bushings or a shift knob. Like I started making shift knobs all the time. Somebody would need something, I'd see if I could make it. So I was able to always ask questions. I was always allowed to make my mistakes, even after I asked how to do stuff, and then be shown how to do things. I did have and still do. They're right next to me now, the machine shop. And I go over there and still use any machine in there and ask questions all the time. He's just been in the business as a machinist for a long time. So in the machining world, he's taught me a lot for sure. But he's a very old school guy who does all hand coding. And, he's coming around to the cam side of things because I've proofed it to him a lot. Like if he'll have something kind of complex, he'll give it to me to cam for him, but he still does all hand coding stuff. So a great resource.
Okay. Let's just talk about that element there, hand coding and cam. Can you expand on, first of all, what cam is and how that sort of integrates? I think let's come back a step. I think a lot of people these days who have seen maybe someone do some 3D modeling on the likes of SolidWorks and some intricate part, and there's an expectation that you just press print and it goes to a CNC mill or lathe and your part pops out the other side. There's a few steps in between?
Yeah. Yeah, there's a few steps in between.
All right, let's talk about those steps, because I think this is a common misconception that we need to sort of clarify.
Yeah, we're not there yet. So there's a few steps in between. Let's see. So you design a part, you have a part, you're ready to get it made. You want somebody to put a chunk of material in a machine and press a button, and that doesn't work. So you have to go through. Okay, I guess let me go back. So hand coding, it's literally writing out all the G code, telling the machine every move to make, every process, every little subroutine for anything. And then CAM is you're going to sit at the computer and apply all of your tool paths and set up all your work coordinate systems, apply all your speeds and feeds to all your tools, which again, if you were hand coding, you have to put in what RPM it is, how fast it's going to be moving. And then I guess from there, you load the program in and hope you got it all right and don't crash anything.
So essentially, CAM, computer-aided machining, it's creating that G code, the toolpaths, etc., feeds, speeds, everything, rather than you having to manually do that. And I mean, I'm assuming, again, this is right on the very edge of my level of knowledge. So, I'm definitely don't have expertise in this, but I can only assume that hand coding, particularly for even a moderately complex part, that must be hugely time consuming and open yourself up to the potential for mistakes.
Like a decimal in the wrong place. Yeah, that could do that. Yeah, it's very time consuming. And if you want to make any changes later, you have to comb through or at least know where you're at and start adding all those changes. Or if for some reason you completely change the profile a bit, if you were going to go around a contour, the start and finish of every arc is its own line of code. So if you change that, it's a lot of changes to make. Where in CAM, you can change to an extent, you can change profile or hole location. And a lot of times you'll just regenerate it and it'll redo the code and pop it back out to what's now representative of the model.
Okay, I mean, this is all making perfect sense to me that would be a time efficient and much more robust way of creating the G code that the machine actually needs to operate off. How much user input is required in this CAM software to actually create that G code versus how much of the process is automated?
There's still a lot. You have to tell it speed, feed. You have to set up the tool. You have to make sure that the tool is correct as far as length of cut, how far the tool is sticking out of the holder, the approach, how you're going to go about machining apart, the order of operations that you're going to go through. None of that stuff is just automatic. There are some things that, like major material removal, there's adaptive clearing where you can tell it, like, here's the whole part, look at the 3D model, and you can set a few parameters as far as stock to leave, like how much to leave before you start getting close to your final numbers. And it'll just apply a whole bunch of adaptive tool paths, which kind of rough clear out a part. Like imagine you had a piece of clay and you were making something inside of it and you just start cutting away, huge chunks before you get into the fine detail. That's somewhat automated, but you still have to tell it where you want to do it, how far down you want to go, what tool you're going to use, what speeds and feeds are right for that tool. So there's still a lot that you have to know. It's not, here's your part, load it in.
Okay. Yeah, I think that should clarify for people a bit of that process. And again, it's not quite as simple as design your part and press print and out it pops. In terms of that technology, is CAM still developing? I mean, is it likely that in time we'll get to a point where a lot of what we've just talked about will become completely automated within the software?
To a point, it very well might. Fusion now they might have in the past too, but they have like drill hole recognition where it'll just look at the model, see all the holes you have, see if it has a chamfer, and just spit out kind of a handful of things like, you want to use this tool? Do you want to use this spot drill? Are you going to tap it? Is this the right tap? And just spit out a whole bunch of code, which all your operations are off to the side, and you can go through and then look at them and be like, actually I want this spot drill angle. Maybe I want this a little heavier or deeper. And that's pretty automated to an extent. But yeah, I think at some point it'll probably get there. Some of it, like we have a lot of the tool library, all the tools that we use constantly, they're sort of set up for what material, speeds and feeds, and you can sort of just drop those on and kind of set it and forget it a bit because it's been proven. But yeah, you got a new tool or you're into material that you don't normally cut, you got a good guessing game and a good base point to start from, but there are a lot of variables that you just have to end up sitting there tweaking and figuring out.
I guess as well on this point, for those who are listening and maybe are dabbling with some 3D modeling and intending to outsource their machining work, Is the cam side of things something that enthusiast would need to learn and understand, or is this something that, a jobbing workshop that you would get that part made, they're actually doing that from your 3D model?
Yeah, they're going to be handling the cam for sure.
I'm guessing there's some liability for their tools as well.
Oh,
If that G
absolutely.
code was wrong, it could actually do some serious damage, correct?
Yeah, it definitely can. So most people would not. I wouldn't have, if somebody was to come to me and be like, "Oh, I have this all cammed out. Can you run?" I'd be like, "No, no." It's like somebody, saying that, they have this tune for your car, or, vice versa. And all of a sudden it's like, do you know everything? Do you know everything that's on this
Yeah.
car? It's like, oh, no. This worked on my computer. It worked on my simulation. You should be fine.
Makes sense. All right, we've been talking about some 3D modeling, so let's dive a bit deeper down into that rabbit hole particularly. And I know that you're utilizing SolidWorks in particular for the design of a lot of the stuff that you're actually building and fabricating. How much, I guess, has 3D modeling software changed the landscape for motorsport fabrication as far as you're concerned?
It takes a lot of the guessing out for some things, for sure. You can have an idea in your head, and then all of a sudden you kind of model it a bit and you realize that there's no way that's going to work. I mean, that happened on the drag car a lot. I'd have a great idea and then all of a sudden realize like, nope, that's never fitting there. So it's a big game changer, I think. If you're efficient in modeling, it can really save you a lot of time. I've been able to model and print, at least print a part to test, or print jigs for things, or print, I've printed a set of dies. I printed a couple weird, very useful parts, and it's just stuff that you can get there. I mean, honestly, you could probably get there sometimes about the same amount of time as if you started modeling it and printed it or something like that, but your success rate is much higher.
I guess if you want to go to the trouble of modeling an entire tube chassis setup in the likes of SolidWorks before you start, you've got that ability to test, maybe the articulation of all the suspension joints, etc., the steering geometry, and make sure that you're not going to have anything collide with any other parts, which can be a little bit more hit and miss maybe with just freestyle fabrication.
Sure. Yeah, it definitely offers that as an option. You could still mess that up too if you model your stuff wrong, but
I mean, it's always a case of garbage in, garbage out.
Absolutely.
So yeah, point taken. In terms of the skill set, because obviously the skill set for operating software like SolidWorks, Fusion 360, etc., is quite different to the skill set required to lay down a high quality bead of weld. So how did you get involved in that, and what were the challenges involved in learning the software?
Let's see, probably around the time when I was at Injuku, I started modeling a bit, and then at the machine shop I'd model parts because they did everything with just 2D AutoCAD. So I'd model some things and be able to pull like a little shop print and print it out, go to the lathe and make stuff. But basically, I was pretty self-taught. I did for a few, probably 6 months to a year, would just pick up something and grab a pair of calipers and just draw it. Like I grabbed one of my coilovers that wasn't on a car yet and sat in my room late into many nights, just taking it completely apart and drawing every single part of it. How are you going to draw a spring? I don't know. Let me figure it out, and start figuring out some helixes and having sweeps over 3 sketches. And if you can't figure it out, just diving into YouTube to see if somebody has a tutorial. Or SolidWorks had a lot of really good tutorial. I mean, I'm sure they still do. You just go to that little side menu and start going through tutorials and learning how to extrude a part, how to make a hole, how to add a chamfer. It's one of those things that the best way to learn it is just, practice and diving into it for your own thing.
Yeah, absolutely. I think these days we're sort of spoiled with options for, tutorials, as you mentioned on YouTube. I'm not sure when this is going to come out versus when our course is out, but we are just currently in the recording stage of a 3D modeling course, which is very specifically focused around the motorsport industry. So I know that that's going to be hugely helpful, but like anything, practice makes perfect as well. It's going to take hours sitting in front of the computer, actually using the software to become familiar with it, so to the point where it becomes second nature. And there's always a bit of a a frustration level when you're first starting anything new, getting yourself up to speed with it. So, you've got to sort of push through that initial phase and, start seeing some progress, and then it sort of becomes self-fulfilling, I think, to a degree. In terms of the software options around, you've mentioned SolidWorks, or we've talked about SolidWorks. There's also Inventor and there's Fusion 360. I think probably Fusion 360 because for personal hobbyist use, it's essentially free, has become the kind of go-to. SolidWorks and Inventor are both more sort of professional level paid software. What's your sort of take on pros and cons of the three?
SolidWorks, I started with it, so I know it, and I really like it. It's very intuitive. It's just super familiar to me. Like I said, when I was learning it at one point, I did go take like a week-long little course thing. The best thing I learned from it was fully constraining my sketches, because I'd be in it and I'd have this model all done kind of, and I'd go in and all of a sudden I'd grab an entity and drag it, and all of a sudden the whole thing is all screwed up. And yeah, so it was like a basics class, and I was in there, I'm like, man, I know a lot of this already. And then they talked about that and I was like, oh, and that was like a big clicking point. But I mean, after SolidWorks, I have played an Inventor when I was building stairs, because he had AutoCAD and Autodesk, so I played with it there. It was very similar to SolidWorks, but just being used to SolidWorks, I automatically kind of didn't like it. It was very similar, but I didn't know where, all my buttons were, and, all of that. And then lately, probably the past year and a half, I've been pretty deep into Fusion 360, mainly for the CAM factor of it. Basically, if I have something that is going to end up getting machined, I'll just design it in Fusion. I kind of like force my hand to learn it, but there's still a lot of times where I hate it because it's not SolidWorks. It's just there's just one thing my buddy Garrett, who he ends up doing a lot of programming, I'll just call him up and complain about it. He's like, what's wrong? No, this is really great. I'm like, no, it's not. This is terrible. So and it's just a personal preference. I can do this in SolidWorks, and I probably don't know how to do it in Fusion, and it's real frustrating. But Fusion's really great because the community around it is huge. I mean, it's mainly what you were saying, the fact that everybody can get into it at such a low entry cost or no cost, and it's turned into this huge community where there's so much online references to stuff that if you have a question, if you didn't try to find the answer, you probably can if you just looked a little bit. So
yeah, and it's definitely been a game changer for that hobbyist enthusiast market. I mean, what you're saying there is understandable. I kind of get the same with different aftermarket engine management systems. I'll have the ones that I use frequently, day in, day out, and obviously I'm totally familiar with how that software works, the hotkeys, the shortcuts, etc. And I can produce a tune quickly and efficiently, and I'll get on another system, and obviously, essentially, they're doing the same thing. They're providing fuel and they're providing spark, but the user interface is different, the hotkeys are different, and there's that learning curve, and you sort of end up just with a level of frustration. I know that they take it to another tuner who has the opposite experience and is very familiar with the other ECU, and they're going to have exactly the opposite sort of experience as well. I mean, while there obviously are differences, both subtle and maybe not so subtle, is it fair to also say that the fundamentals of 3D solid modeling are the same, and if you understand those, you could adapt to any of those three software packages?
Yeah, absolutely. One of the things ingrained from that SolidWorks course that I took was simple sketches, multiple features. And I mean, I think that carries into all of them. If your part's starting off as a square and it has a bunch of holes in it, just draw the square, and then make your holes. One step at a time, you just nibble your way through the part, and you'll have a whole part. So yeah, the basics definitely carry over through all of them, I would think. I mean, in anything. I mean, it's probably the same with anything. Just little nibbles through everything, and you can end up with a really cool part.
Absolutely. All right. Another thing I want to talk about here, and this sort of almost is similar to what we've just discussed with the fact you can't just design a 3D part and send it straight to a CNC machine and have it printed out the other end, or machine it out the other end. There's some steps in between. I think there's the same level of misconception out there, and I think Instagram probably has a lot to blame for this when it comes to the technology around 3D scanning. And I think, again, for the layman, there's this misconception that we get someone in 3D scan an engine bay or an engine, or for that matter, absolutely anything, then that just gets magically imported into Fusion or SolidWorks or whatever your preference is, and it's all there dimensioned, and we can just start using that to then build parts around. It's not quite like that.
No, I don't have a lot of experience with 3D scanning. We've gotten to scan a few parts, but there was a part recently which was slightly organic. It had some weird radiuses and kind of sweeping curves to it, and I had to machine it. So I was handed a part which was originally a casted part. I measured it about many ways that I would: calipers, angle finder. Sometimes I'll get a 2D sketch and just print it and then lay it over a 2D printed, just on paper, and just see if it's right. And maybe I'll tweak this a little bit. And I got my part. I modeled what I needed, and then I was able to go get it scanned and hang out for the process of scanning it. And it's with a nice ferro arm, like a blue light scanner, has a probe on it, so it wasn't a low end scanner. The person I was working with, they just got it, so they weren't incredibly efficient, and they were showing me the process and kind of teaching me through it. And I actually ended up doing the second one of it. But the process itself it's cool and great and has so many amazing features, but the time it takes is about the same, and then you end up with just this point cloud. Or if the software can do it, it will just give you a surfaced part. But if you have a surfaced part, you usually can't just go and machine it. It acts as a visual aid to design around, kind of, is what I've really, sort of submitted to accepting it as right now, because really that's what it's best for. You see people scanning engine bays and then designing this whole thing, and most of the time it's just a point cloud or maybe some surfaces there to just give you a boundary to work inside of. It doesn't allow you to just build parts right on it most of the time, because you have to end up modeling it anyway. So it's awesome. It's going to get so much better, but it's not as cool as you think it is right now for me. And I'm not efficient in it, and that's my experience with it so far. But
yeah, no, that's fine. I think that's all we really needed to talk about. So I guess to take it one step further, to really sort of fill in the blanks here. So if you had taken that cast part that you were talking about there, and you'd scanned that, what would be the steps required to then go from that scan to be able to essentially machine or 3D print, basically to build a model from that scan that could be used for further tasks?
To my understanding, it becomes a matter of dealing with the software to patch all the surfaces and create a model which you can then either, should be hollow, I believe, or you have as a good visual aid to start modeling your final part in and make sure that it fits, and you can turn the one on, turn the other off, and make sure that it's what you want. Because what you scan and what you get as far as surfaces isn't what you want to drive tool paths off of. They'll have inconsistencies, they'll have a little divot in it, it'll kind of figure out its own little thing to make this patch over this glob of flashing that is on the casting. So there does prove to be a good amount of post work that you have to do. So really, again, like I was saying, it becomes just a visual aid to then compare your actual model to inside of it, or you can then pull measurements from it for sure. I mean, you can pull lots of measurements and get things that there's no way you're going to do with a set of calipers, or find these angles, or you can push a plane midway through a part and get a cross section of it. There's all these amazing things you could do with it, but you're not scanning something and just applying tool paths to it. So
yeah, okay. All right, I think useful to a point, but maybe just really wanted to point out it's possibly not what a lot of people think it is at this stage, and maybe in time that will come. Now, we can't probably have any discussion around 3D modeling without also talking about 3D printing, additive manufacturing, and this is something that's really come of age, particularly in the last decade or so, maybe even the last 5 years, with the cost of 3D printing equipment just coming down so dramatically. How useful is 3D printing to you in terms of prototyping or even making final parts?
it's super useful. Being able to model something, think it's great, and then print it and realize that it's just doesn't fit or it's not going to work saves so much time.
I assume also saves a lot of money compared to actually sending that part out to be machined out of alloy or whatever it might be. That's obviously going to be a lot more costly than a 3D printed part.
Oh yeah, absolutely. Yeah, the cost savings and time savings it's huge. It's really changed the game for me because I'm able to make kind of some weird parts, and some things I've sent out to like get printed out of nylon to hold parts, and it's really cool. And I've been lucky enough to go print aluminum plenum, and that was just not possible to machine, and the time savings was incredible. I mean, if it was in a perfect world, it could have been like a 36-hour process, I think, to have a modeled part finished to go weld it. So it's amazing.
Let's talk about that angle and specifically here with the alloy plenum that you've just mentioned. So I believe you're referring to the plenum that is for the Nissan SR22VE Turbo, which we're going to talk about in a bit more detail. That's the one where we're on the same page here?
Yeah, that's it.
So this, from what I've looked at, and again, people can scroll through your Instagram, which we'll talk about a little bit later, to find some photos of this. But it looks like a dual plane plenum design. You've mentioned here sort of additive manufacturing, 3D printing. You can produce parts that would be difficult or maybe impossible to manufacture using traditional fabrication or even traditional machining operations.
Yeah, for sure. Basically, it's not a true dual plenum, I guess, to be fair. It was designed out of a necessity of packaging. And while doing so, I started being able to look at there's some internal vanes to help direct air, and it's just not possible to machine. It would have to be two pieces. The cost of billet, the time to program, all of that would just be pretty close to on par, I think, with actually printing one. So we were able to just kind of go forth and get one printed, and it allowed to, basically make something that I couldn't machine, and it would have to be multi-piece.
Obviously, there's a budget that's gone into this car, which is not small. The process of 3D printing alloy like this, is this horrendously expensive, or is it sort of getting to a point where it is something that could be considered for the average enthusiast who isn't sort of pouring paycheck after paycheck into their car?
It was still quite expensive to do. I've had some people reach out and be like, "Oh, can I get that?" And I'm like, "Yeah, sure. It's about this much." And they're like, "Whoa." So it's caught some people back, but people also don't realize the time and cost that it takes to make one-off parts. So if you're gonna say we just split that plenum in two and we machined it, the cost of billet and then the cost of machine time and the cost of it possibly not machining well or correctly and scrapping one or breaking a tool, everything that goes into doing it, it warranted making the part and getting it printed. So it's still quite expensive for, I think, most things. Definitely in certain budgets, it's absolutely acceptable. But, again, it allowed it to have some features that wasn't going to happen through traditional manufacturing. So it's awesome. And it came out right the first time. So that's worth a lot in itself.
I think probably as well, we need to understand that most people, when they're looking at aftermarket parts, they're probably comparing something like this one-off 3D printed plenum to a production part that the manufacturer is making hundreds, if not thousands, of these parts per year. So there's obviously, when you're in production with a part, there's a sort of benefit of scale in terms of bringing the cost for each of those parts down versus a one-off. So that's something we do need to consider. The other thing as well is I can only assume, as the technology improves and time goes on, the cost of these 3D printed metal parts is also probably going to come down a lot. So is that sort of a reasonable assumption?
Yes. The fact of when someone sees something and they think of what is already mass produced and compare the cost it happens all the time. It's the worst thing ever. And I think 3D printing is absolutely going to start to come down. I mean, you already can, I think Glowforge has like a metal printer that you can get at your house for, not $1 million. So, it's going to start coming down. It's going to start being probably offered overseas, most likely, where you can just get stuff printed for so much cheaper than you can now. I mean, I would imagine it just seems the way things go usually.
And I assume it will just follow the same path that we saw with, conventional 3D printing as well. And the cost of those machines has come down so dramatically. They're now genuinely affordable by just the average home enthusiast. So look forward to that day. It might be a few years off just yet, but we know that's probably coming. Just on that plenum design, you mentioned turning vanes, and with difficult without the benefit of pictures here, but again, people can search that out. Maybe we can drop a link in the show notes to make that a little bit easier. But that I mentioned a dual plenum. You've said it's not quite a true dual plenum, but one of the considerations with any plenum chamber intake manifold is trying to, I guess, equalize the flow into each cylinder so that we don't have sort of unequal amounts of fuel and air being combusted in each cylinder. Is there anything that you've done there in terms of CFD analysis, or is this sort of more of a gut feel kind of design?
Yeah, it was definitely a gut feel design. It would be hard to really deal with true CFD without having like real backed data to compare and actually run through simulation with. So it was kind of a gut design, just sort of a general practice of what air should do. And, it wasn't a hard divided guide. There is one single split to sort of get to 1 and 2 and 3 and 4, and then another 2 little guys to just sort of guide them towards the correct runners, and hopefully do their best to get air to everybody. On one end, you can probably say that might not work, and then the other guy's going to say, oh, it's a turbo car, it's just cramming air, it doesn't care. So
I mean, I think there is definitely an element of that with any turbocharged engine. They seem to be in almost all ways a little bit more forgiving than a naturally aspirated engine, but there are still basic principles that we want to follow, and try and get it at least as right as we can. Correct?
Yeah, I mean, that's basically what it was. It's just, does this seem like a good idea? Is there a wall blocking anybody? No. It's gotta help.
Sometimes common sense goes a long way to getting a design sort of 80% across the line, I think. Let's move on and talk a little bit about exhaust manifold design, particularly around turbocharged engines. And this will sort of lead into the discussion around the Mazworx / Shane T sort of compound triple turbo setup for the SR22VE turbo. When it comes to exhaust manifold design, and maybe not specifically just for that car, but obviously there's a lot of considerations that go into it in terms of where the turbocharger is going to be located, how you're going to run the primary tubes into that, and the collector design, etc. Are you using anything formally to help you with the design? Are you modeling that in SolidWorks? I mean, here at HPA, we've got the ICE EngineWorks header modeling kit, which sort of lets you kind of mock up a header and kind of get a sense of where it's going to run before you actually start working in stainless material. So yeah, what's your take on that?
Since I modeled the entire drag car mainly, I was able to design the manifold all in SolidWorks, and I was able to just basically look at what centerline radius bends I was able to get, and then from there, more or less, I tried to make everything equal length. What we tested with on the engine dyno I knew worked, so I didn't try to stray far from that. So we had that same, it's actually the same collector. And then as far as runners, the furthest one I got as smooth as I can, and then use that as my baseline of what my runner length would be. And then basically ran everybody to get equal length from there. And the same thing, just kind of a common practice thing. I used the biggest centerline radiuses that I could everywhere that I could, just to have the smoothest flow, and then fed it all to the collector. And it, again, with probably every manifold, it became a big packaging game. If I wanted to use, like I said, I wanted to use the biggest centerline radiuses to have like the smoothest flow, but you couldn't always do that to get where you needed to go. So you got to step down to the next one, and hopefully not the next one to get down there.
So there's always some compromises along the way. In terms of the runner length, for example, is this driven by math, by physics, or simply by a packaging constraint?
Mainly a packaging constraint. Like I said, what we ran on the dyno, so I had that and knew that more or less worked. And then from there, it became a packaging and availability if I could get from number 4 to the collector, that length in itself from number 1 to the collector, which is the closest, that's already going to become an odd game if I was going to try to make anything longer. So, I just, like I said, stuck off the last one. The furthest runner that I had to deal with is kind of where I started.
Yeah. And I think it's fair to say that if we're looking at a naturally aspirated header, there's a lot of math that goes into the design of those and the optimal lengths, and whether it's going to be a stepped primary, 4-2-1, 4-1, etc. And that, as I've experienced with dynoing several high-end naturally aspirated engines, there's a significant effect that has on the power delivery and the power curve of the engine. And I mean, I can't say that doesn't go for a turbocharged engine, but again, kind of like we were talking about before, I think there's the turbo sort of is a little bit less sensitive perhaps to some of those elements. And I mean, also, it's not too often that we get the ability to back-to-back test sort of 3 or 4 different manifolds on a turbo engine with significantly different runner lengths, primary diameters, etc., to really get a feel for what is the optimal. It's sort of more of a case of we design something, we build it, we put it on the dyno, it works, it makes the numbers we're looking for, so we kind of move on. Has that been your experience as well?
Yeah, especially with this one too, because it's such a open the valve, make all the power you can. There's no sort of power band you're trying to live in. You're not trying to have a great responsive setup. It's just, this is what worked. So that's how it was designed for this one for sure. And other things, I did play with stuff. On my personal car, I built a really long equal length manifold just to see if it would be any different for having longer runners compared to kind of that normal ram horn style for most 4-cylinders. And they got pretty long. I think the runner length on them might have been something like 25 inches, which it runs kind of forward. I actually ended up moving my power steering pump after the fact because it got in the way. But my car is personally really responsive, but I don't have a back-to-back to compare it to, and I don't want to go pulling it off to put another manifold on just to see, So again, I think it's kind of one of those common sense general practices. What's a good idea? What's a normal size? What does most people do? Kind of if you get outside of the box on runner diameter and length and stuff, you might end up in the weeds, and there's probably some people that have done a good amount of research to figure it out. So I kind of just lived there with that.
Yeah, that makes perfect sense. Let's talk about the materials that you're using. Obviously, there's a range of different grades of stainless. There's also like 321 is common for high-end turbo headers. What's your sort of go-to?
Most of the stuff that I've dealt with is 304. This one was 321 just because of the high temps and stresses it's going to see. Outside of that, I've played with titanium a bit. I haven't gotten to do any Inconel.
In terms of those three, let's talk about 304 versus 321 versus maybe Inconel. What is the sort of benefit, at least with 321 over 304? Is it just able to withstand more temperature?
It does withstand more temperature, and you're able to run a thinner wall, which becomes a weight savings for it a lot. And then same with Inconel. It is more expensive though, so most people don't go for it.
So you did mention, I think you just said you haven't actually worked in Inconel, was that right?
I've machined some. I haven't gotten to weld any, no.
Okay. Are there any sort of intricacies or special techniques required to weld Inconel in comparison to 321 and 304?
Like I said, having not actually welded it, I don't know firsthand, but like anything, it becomes a game of cleanliness and prep. For any welding, you want to have the best prep, the best fit, be extremely clean with your filler rod, have correct gas coverage. You want to back purge all your parts. So I would guess, I would approach Inconel in the same fashion.
Sure. Can you give us a sense of maybe orders of magnitude of the cost difference between those three materials as well?
Last time I checked, and prices have been crazy lately. Everything's kind of jumped around, but usually 321 is like 2 to 3 times what 304 can cost.
Okay.
And then Inconel, I haven't priced it, but I would imagine it's more than 321, maybe 4 times the cost of 304.
All right. So there's a reason why you tend to only see Inconel at the sort of highest levels of motorsport then.
Yeah, absolutely.
All right, so we've talked a little bit about the welding, and I want to get a little bit further into that. But before we do, let's talk a little bit more about the design around this particular manifold application. I mean, it's sort of blown up the internet recently. We actually ended up doing a tech talk with Shane T at the Mazworx stand with all of your fabrication work sitting on display behind us back at PRI 2019. And that's a really deep conversation with Shane about compound turbocharging and what he was trying to achieve with that particular engine. If memory serves correct, he was aiming for 3,000 horsepower out of a four-cylinder. So if people want to find out the deep dive into that, we'll link to that YouTube video in the show notes. But could you give us sort of a high-level sort of understanding of what compound turbocharging is and what was trying to be achieved with this particular project?
Yeah, basically, from what I understand, it's explained to me, you couldn't get a big enough turbo to move the amount of air needed to make that power that SR could actually get spinning up to speed. So that was the game plan, to go with the three. So the two up front technically act as a one turbo. They're all being driven. I mean, it sees all the exhaust gas at first, and then it gets the middle or the second stage spooled up to get all the air just started crammed in. Basically, I mean, out of the exhaust, it's into the collector. There are two wastegates there to bleed off whatever we don't want the second stage to see. The exhaust that may run through that turbo all comes and wraps back around and splits off to the two up front. Once those come online, then the wastegates start to play the game of keeping everybody in the range where they want to be, so that basically all the turbos right now are hanging out in a happy efficiency range. Everybody thinks that they're just making like 40 pounds of boost, when in reality, I think it's around like 120, 140, something like that.
Yeah, again, without diving too much deeper into the technicalities, you sort of get a multiplication factor of the boost. And the problem when you've got such a small capacity engine, 2.2 litres, trying to make 3,000 horsepower, you're not going to be able to find a compressor on its own that's going to be able to efficiently do so at the sort of pressure ratios you need to run. You sort of end up kind of off the compressor map. So the multiplication factor allows you to use two, or in this case three turbochargers, where each one you're sort of operating in an efficient area of the compressor map, yet as you say, the boost pressure that the inlet manifold is actually seeing might be, well north of 100 psi, which is difficult to support with efficiency on a single turbo. From your perspective, obviously the design it was a bit of a brainchild, I guess, of Shane. And how did you get involved in the project at the first instance?
So my neighbor is Kevin with KSV Looms, and Ralphie Navarro that's the man who owned the car. He sent a car over to have Kevin build a harness for, and that then needed to have a new turbo put on and some associated piping and whatnot to make that fit. Since I was next door, he said, "Oh, you should have my friend JT fabricate this." So the plan was to basically build this Corolla with a 3TC and just build a fun car. They've all been friends with Shane. I mean, it kind of came through Shane as well, because it was one of his previous customers through motorcycle racing. So I had the car. We're doing this Corolla. I believe he lives up north. So when World Cup was going down, he went up to Maryland to hang out with everybody. Then I guess over some drinks, probably, Shane said, I got this idea, and he wanted to do this compound turbo setup. And Ralphie's a really amazing guy, and he just said, "Okay, let's do it." And they're like, "All right." So then I'm in this group chat because we were kind of all involved on the Corolla, and all of a sudden it says, "Hey, we're going to do this compound turbo setup with 3 turbos." And I'm like, "Oh, okay." And I kind of thought it was a little bit of a joke. And they're like, No. Like 3, there's going to be 2 that feed 1. And I'm like, "Oh, okay." And so then it became, let's figure out how to do this 3 turbo compound turbo setup. And we took the SR from the Mazworx S15, they brought the dyno cart over to the shop. Yeah, they sent me 3 turbos. I think we originally used the original precision turbo that the car was running, but nonetheless, they sent me 3 turbos and rolled over the whole powertrain setup that they would go to the dyno with. So it had the intercooler, a fuel cell, everything mocked up to bolt up to the dyno. I said, "Here you go." I basically got a fresh collector, and put 2 more gates on, because with the turbos they sent me, here's 2 gates, here's 2 more intercooler cores for the first stage, because there's a intercooler stage between the 2 in the front and the 1 in the middle. Basically, I just had a whole bunch of parts show up, and I grafted everything onto it, and it all just stuck out to the side.
So this was just for the dyno proof of concept cut. So this was, at this stage, you had the flexibility to kind of put the parts within reason where they fitted without really worrying too much about how it was going to fit inside of a chassis.
Yeah, I kept them as close as to not have to do anything real crazy. But yeah, I just stuck everything to the right side. So I got 2 turbos just kind of towering over the manifold, a whole bunch of exhaust coming off the back, kind of wrapped everything around. There's an intercooler off to the side. There's, I want to say for the intercooler, we had a little ice tank that just sat on the floor to run water, and another pump to run water to that. So we brought all that. It looked crazy. My constraints was told, make sure it fits through the door. So
yeah,
that was
probably helpful.
Yeah, make sure it fits through the door.
Pretty hard to dyno it from the car park.
Pretty much, yeah. So got that on, went to the dyno. We didn't break the dyno, but we were basically doing burnouts on the dyno. It took a minute to get the turbo to come up online. And once it did, there had to be enough load on the dyno to have it come up and start to make boost. And then once it made boost, it would just run past the dyno. So basically, we didn't go back to do it, but the plan was to then have the Motec control a valve on the dyno to play with the load that the dyno is going to see to be able to hold it. But basically, it made 2170, something like that, but only at 9,500 RPM. And they were going to, I think, 11 or 11.5 that day. And in that like couple thousand RPM, there was a lot of power to be made. And it was already at like 110 PSI, I think. And it was blowing a coupler here and there. And then the dyno was just not having it. So after that, they decided that this can't fit in the Corolla. Part of it was the tire that we're going to have to run to put in the Corolla was really going to start to mess with the way the car looked. We're going to have to start stretching things, maybe widen stuff, and it wasn't going to be in kind of the spirit of what the car was. So let's just build a whole car. And I was like, oh, okay. And
this escalated quickly.
Yeah, it escalated very quickly.
It sounds like that round of drinks with Shane was pretty expensive.
Yeah, I wasn't there, so I don't know. But I mean, that was after the dyno was when it turned into another car.
Okay.
So yeah, they said, let's just build another car. We'll build a whole car. We need a car that will go 5s. At that point, I mentioned like, hey, I've never built a drag car before. I don't know if you want me to be the guy building this. And he goes, no. I want you to do it. I think it's going to be really neat if you're the one who builds it. And, we have all these people kind of from different worlds. And I think it might be neat to have a different take of a drag car that's not built by, a drag car guy, to not always do it. Like, this is what drag car guys do. This is it. Not downplaying it, but this is the part. You just put it on, it works, and this is what we do. If I didn't know, it allowed me to kind of make things a little differently from the world that I'm used to.
Yeah, do you think that's given you an advantage? I mean, obviously there's a number of very well respected specialist drag chassis builders in the US, and for that matter all around the world, and that's what they do sort of all day long. I mean, given my own experience in drag racing, which was always with a factory monocoque, so not quite the full tube sort of 4-link rear end style of things, but there's a lot to that rear end and the geometry and everything else about the tube chassis that really becomes critical in getting the car to 60 foot to get it to go straight consistently. And obviously all of that adds up to the ability to run into the 5s or whatever. Is that daunting coming into building something like that you've never done before? I mean, obviously no one's ever done something until they've done it for the first time, so there's an element of that to consider. But tell us about sort of your thought process with it.
Yeah, like I said, I don't think you want me to do this. So it was pretty daunting, but everybody in the group that we were working with, they were all there to help, in the sense if I had any questions, hey, is this right? Is this where you want this tube to be? Because we added a whole bunch of different tubing than what was originally or usually put into a chassis. So all that input came from well-known people in the industry who's in this circle to get this car going. So I had some great people to ask for sure, but in reality, it's pretty daunting because, like I said, I came from the road race world where it's a unibody car and you're gutting it and putting a cage in. You're lightening it as much as you can. I haven't built a whole chassis before, and modeling it definitely was an awesome route to go, because then when it became time to start playing the packaging game, it was a little glimpse into the future instead of just standing there with a big U-bend of stainless going, does this fit here?
So the ability essentially to know before anything is cut or bent that it's all going to fit as you expect.
Yeah, it's super useful and eye-opening, because you'd have a plan. I'd go, this should work. This should be okay. I'd start modeling parts up. I'd put them in. I'd pull this centerline radius. It looks pretty good there. I don't think it's going to hit a tube. And I'll sweep the diameter, and it's all the way in a tube somewhere, all the way in something else. I'm like, oh, okay, that's not going to work at all. Yeah, not at all. So it's like, okay, now I have to move the initial part that this is all, anchored to. So yeah, it's super, super useful, and to my knowledge, not common in the drag world. I don't know, I don't know how those guys always build their cars, but every time, Shane came in or anybody came in, they looked at it, they're like, people aren't doing this. Like, this is a little out there. So
I definitely can't say that it's not being done anywhere, but I haven't also seen that being mainstream. So perhaps you're onto something there. In terms of that, when you're sort of designing all of these parts in CAD, does that give you the ability to have the roll cage, for example, or any of the parts of the tube frame chassis sort of CNC bent and notched, or are you doing this by hand?
Yeah, all the chassis I sent out to get CNC bent and notched showed up on a pallet. It's like a giant play set to put together, which was really awesome and was a major time saver. I mean, like I said, not having built a full tube chassis, because when you're fitting like a main hoop into a car, a unibody, if you don't do it every day, it's a little bit of a task to make sure you bend the hoop first try and get it to fit in nice and tight and, not compromise in places. So building a tube chassis, I'm sure there's a little bit more freedom there, since you got to be within the body, but it's just a silhouette of carbon. So you definitely have some more room, but being able to model it, the time savings seemed huge. Because of the cost. I mean, what it worked out to, I think, was something like, at my labor rate, it was going to be 54 hours or something. I would have had to have bent and notched an entire tube chassis. And I was like, there's no way that this is going to happen and not make a mistake, not waste any material, which is all chromoly, which gets a little expensive. So it was an awesome way to go. And again, it allowed me to build off of the tube chassis and then start fitting all these parts. I mean, if I didn't model the chassis to get cut, I wouldn't be able to then play the game of where does everything fit.
Yeah, I guess it's one of those things you either do it all or you basically do none of it, because it's not going to work if you don't have everything modeled, correct?
Yeah. I mean, I've always seen like all the off-road guys, all those trucks are like full CAD models, and they got giant fixture tables, and they laser cut all these jigs for building the chassis. And, like I've seen it, I'm like, oh, this is the way to go. This is the best way to go. So as soon as I got the opportunity, I went for it.
No, it makes perfect sense. I'm interested, when you get those parts, those tubes back from being bent and notched, are they absolutely perfect? Are they exactly like your model? I mean, when you're manually bending tube, there's a degree of spring back that you have to account for. I mean, I'm guessing that's also accounted for automatically with the CNC bender. But yeah, I'm just interested, does it literally come out perfect, or is there like a little bit of tweaking required?
So when I was working with them, getting them bent, I asked, hey, what are all the centerline radiuses supposed to be? And they just gave me, a list of everything that I had to do. So I went through my model and changed everything to what their centerline radius resulted in. So I'm sure that helped. And then as far as fitting after the fact, if it was a straight tube on a straight tube, it fit 95%. I mean, I always cleaned it up with like a drum sander just to get into fresh material and make sure that there's not a little booger from like the laser or anything like that. But it was really clean from the start. Just kind of the OCD side of it made, make sure it's like perfect.
Must be satisfying.
But as far as putting it together, yeah, it was extremely satisfying. And then I'd go back and forth from the model and go, okay, from, this tangent edge to the start of, the crotch of this tube or where the tube meets. And I'd mark out everything kind of perfectly as I was fitting each tube, so that when I got to 12 feet at the other end or something wasn't totally off. So I think it becomes there can be a big user error if you just loosely start to fit and just weld stuff where, it seems happy if you just assume everything's perfect, then it's like, this is good. But most of them where they were supposed to land, they landed. And then the only thing would be if a notch landed on a bend, that would end up requiring a little like hand massaging to get the fit just right. But at the same time, if you kind of didn't care to a certain extent, you could probably just weld it on. It'd probably be fine, but
We'll talk about fit up in a moment, because that does become quite important with the material you're working with. In terms of that centerline radius that you've referred to a couple of times, I'm just guessing here that what you've got to do is deal with whoever's going to be doing the CNC bending, find out what centerline radius they're actually able to manual bend the material on, and then match that in your model, so that basically the model, the part that you're giving them to bend and cut, is actually physically able to be bent to match. Is that what you're getting at there?
Yeah, for sure. Most centerline radiuses, it's usually like 3 times or 4.5 times, something like that, like what the diameter is. It's usually pretty standardized. But like you were saying earlier, when you hand bend something, there's always that spring back. So things aren't always exactly the same. And I mean, I don't know exact numbers off the top of my head, but let's just say it was like a 4.5-inch center line or something like that. I'm pretty sure that their number was like 4.6 maybe, or it was very close to what it was. It was just, hey, what's your resulting center line when it's bent, just so my model is what that is. So it got everything just that much closer. But yeah, it would be a good idea if you were going to do it to ask them and have them tell you. I mean, depending who you go with, they might just say like, oh, it's close enough, but they did tell me exactly what their result was, and that's what I put in, and it worked out great.
Perfect. All right, let's talk about the material. You've mentioned that you're using chromoly, and there's a variety of different materials that can be used for tube frames, for roll cage structures. I mean, at the lowest level, there's mild steel, and then we've got chromoly, and docoal is another material that I haven't personally had experience with here in New Zealand. One of the benefits of chromoly is that it's much stronger than a mild steel, so we get to use a thinner sort of thickness of the tube, bringing the overall weight down for the same strength. But there's some problems or sensitivities around the input of heat during the welding technique with chromoly that needs to be carefully considered for a strong and reliable structure. Can you talk to us about those sort of heat-related problems with that material?
Sure. Yeah, with the chromoly being thinner, basically it usually does take less heat compared to what you'd be used to with mild steel, because most of the requirements for a mild steel cage, the wall thickness is thicker. With TIG welding, you don't want to end up cooking the weld. It can get brittle. It'll harden, and basically I'd manage it just by kind of jumping around. Having your prep really good is another thing. If you leave the mill scale on of anything, you usually need more heat to get through it. So you want to prep your material best you can, get all of that off, nice shiny clean material, and it welds a lot better. You can use less heat technically, and since it's thinner, they'd be single passes, and just kind of don't overcook your weld. Take your time. It's a time game sometimes.
In terms of removing that mill scale, what techniques are you using there? Is it just sort of sanding it off, or what?
I just Scotch-Brite.
Scotch-Brite, okay.
I have Scotch-Brite, yeah. You could use like a higher grit sandpaper as well, but I Scotch-Brite.
And you're sort of wanting to clean that mill scale back a couple of inches from the weld area?
Yeah, definitely. Because, I mean, it is technically like a layer of oxidation, so it has impurities in it, so you don't want that getting into the weld either. It's back to that like cleanliness for all your welding.
In terms of reducing the heat input to the weld, fit ups are a really critical part of this as well. So talk to us a little bit about what sort of fit up you're looking for. How much of a gap is too much of a gap?
For me, at least with the tube fitting and the stuff that I do, I have no gap, and I'll end up depending on what it is, what the thickness of the wall is, but certain parts I'll bevel or chamfer the edge to give myself kind of a little bit of a V groove to kind of fill in, so you're using less heat and kind of building that material back up with the filler rod. And then I know that some things like, I mean, I guess it's unrelated, but you get into like the pipe fitting world, and there's stuff where you leave a gap. That's not the case for me with almost anything I do, but not having a gap also allows, smaller filler rod, because you're not trying to bridge to, the gap between with a larger piece of filler rod, which then you need more heat for a bigger piece of filler rod. So yeah, that's the heat management game, I guess.
I'm definitely not a experienced or competent welder, so I'll put that out there. But I do talk to a lot of fabricators. I understand the processes involved, and I think probably for those who are struggling to get good quality welds, the key really is, as I understand it, all comes before you actually ever pick up the TIG torch in terms of the material preparation, getting that fit up between parts correct, so there's minimal or absolutely no gap, and then that cleanliness which you've touched on. If you get all of those parts of the process right before you actually pick up the TIG torch, then the actual welding process, you're already ahead of the game, and you're much more likely to be able to produce a quality and strong weld. Is that sort of your experience as well? Is that be how you would describe it?
Yeah, once you finally sit down and start welding and strike an arc and start filling, that's like, I don't know, maybe the last like 30% of it. Because all the time, if the more time you spend prepping and fitting and making sure everything's clean and back purging your parts and tacking nice small little tacks correctly, or tacking a lot of tacks to help disperse heat, that's most of it. Like anybody that comes to me and they're just like, hey, I have this little part, I need you to weld it, it's just like 3 little zaps or an inch worth of weld. I'm like, that's not it. Like, that's not the time that it is to weld stuff. It's all the prep. And people want to bring me the parts like, oh, I'll clean it, I'll prep it for you. I'm like, no, I don't want you to. You're not going to do it, to what I want. So yeah, it's a lot of time, and a lot of people overlook it. And I don't know, it's in comparison to maybe painting a car. If you don't prep the car correctly, you're going to see all the, if you don't sand to a fine enough grit, you're going to see all the scratches. If you don't make sure all the grease is off, you're going to get fish eyes. If you don't seal the car properly, it's going to start rusting later. So like, there's all this time that goes into fit up, make sure your parts are clean, make sure the fit's really good. If you got to go back and sand it, if you have to break out a file just to make that gap disappear if you can, and then make sure you have a nice beveled edge, make sure it's an even beveled edge. You want the consistency.
Yep.
It's the consistency game. And I prep all of my parts the same. If I'm prepping steel, regular mild steel for something, I'll prep it as if I was going to weld titanium. It's my standard practice for welding. And since it's just the standard that I have, it's not anything special. It's not something that I'm going to forget when it comes time to do something that's really good. I've welded a bunch of laser cut parts for like some production one time. And it was a part that ends up in a pond. It doesn't do anything special. Nobody cares what it looks like. And I prepped them pretty good last time. And this time I was like, let me just see how these go without prepping them. And I welded them and they welded great. So I somewhat wasted time the first time prepping them, right? But what happens is that's fine for that, right? Because if I'm welding it and all of a sudden there's this like booger of, an oxidized piece from the laser where the gas was off, or I don't know, just some crap that's in the material, right? You're going to weld along, it's going to be going great. And then all of a sudden it's going to blow up in your face. You're going to have this big like puff, something's going to volcano out at you, and that perfect weld is ruined. So yeah, it doesn't matter for the part that's in the pond, who cares? But if you're welding on, this perfect piece of titanium or those headers for, 3,000 horsepower or something, you don't want that to happen. It's not that it's always going to fail because you didn't prep it great. It's the fact that it's going to fail, or it's going to, go wrong or go bad as you're welding it exactly when you don't want it to. So every precaution that you can take to have the best weld you can, you just might as well take it.
Absolutely. I think it just becomes part of that entire welding process, and we cover that in our welding courses. We've got a step-by-step process so that those parts of the process don't get missed. And like you said, I mean, the actual welding part, if you've done all of the preparation and the fit up, you've got that correct, the welding, first of all, should go smoother. It should be easier. Your finished result's going to be better. And as you mentioned, sort of, that makes up about a third of the task. I think for those just getting started, the temptation is, of course, just to jump straight into the welding. But you need to understand that there's a lot more that goes in to it, particularly as well, more important when you're working with some of those more exotic materials like titanium, where the cost of making a mistake is going to be much greater. The other element there is the chromoly. If we put too much heat into that, we end up potentially making the material brittle in the heat affected zone and could end up having a failure if the car's involved in an accident. So there's a safety element that comes into that as well, that sort of the onus there is on the fabricator to make sure that job has been done correctly. Moving on, JT, I want to talk a little bit about the business element of what you're doing. And we've got a lot of people listening to this podcast who are either business owners in the automotive industry or maybe considering that sort of jump into starting their own automotive related business. So I'm interested to sort of know how you decided that starting your own company was going to be the right move for you. What was the thought process there?
The main thought process was the race team I was working for dissolved and I wasn't going to have a job.
So you were pushed essentially.
Yeah, a little bit. No, so I mean, that did happen though. The Grand Am team I was working for, he just, most of those teams are kind of just well-off people that want to go racing, and then they go racing for a while and maybe they don't want to go racing anymore. So it was cool. I mean, I have a great relationship with them still, but they didn't want to have a big full team. I mean, we had 4 cars, 2, rigs. So it was a big operation. And basically when that started to dissolve, figured I might as well kind of start looking for something to do. I kind of always wanted to have my own thing. I think it was like by the time I was 30. So it was kind of close to that. And I had some pretty good contacts in the race industry. There were some good teams locally to me. So I was offered a spot in a friend of mine who worked on the team as well. He had a little shop of his own, just kind of for his own stuff to work out of. And he said I could do some stuff in that space. So I was able to, I think the first thing I did was a roll cage for a guy who had an E30 M3. I was fortunate enough to be able to use the bender that was at the race team. I had my own TIG welder. I had a bunch of my own sheet metal tools. I mean, I had my garage kind of packed with brake and a shear and, a handful of things for sure. So I had a good bit because I had my own projects at my house that I was working on. So I definitely had a bit of a head start there, but I worked on his car. I built that roll cage. Somebody else who was into or ran ST, I did like a fuel system and an exhaust and some other stuff that was kind of in line. We ran some Civics on that team as well. We were running Mini Coopers and then we switched over to Civic SIs. So we were running those. So it was the same car. So kind of we did the same little setup on that car, same out of my friend's garage or, shop that he had. And then I had a buddy who I was able to rent a space with that was actually right next door to the machine shop that I worked at when I was 18. So, I mean, I was in a place where I had a great neighbor who had a machine shop that I was given a key to. And I just kind of, I had a couple jobs that, the roll cage and the other thing. And I had some people that said like, oh, I'll send you stuff. You can do this, you can do that. So I was like, all right. And kind of jumped for it. I think it's the only way you can do it. I didn't have a business plan or what's my model, like how am I planning it? No, I just went for it. And the goal was like pay rent, pay rent at the shop, pay rent at the house, and keep going that way. Have a really cool wife that won't hit you working a lot, and support what you're trying to do. And I mean, it just kept going. I'd get some more teams. I'd always end up at other shops. I'd end up other places still. I was just a hired gun a lot of times. So they'd have, like I said, there's a good amount of race teams around where I'm at, and they'd be like, hey, can you bring your welder over here and weld this up? Hey, we need this made. Can you come out here? Like I said, I had a good relationship with Injuku. So every time it was like Formula D crunch time and they're putting cars together into like, late hours of the night, they're just like, you want to come out here? And I'm like, yeah. And I'd just show up and hang out and eat a bunch of chicken nuggets and, build cars late into the night. And, I just kind of put in all the hours and then they'd have to leave for the track. I'd be like, all right, see ya. And I'd be done.
It sounds like you've basically jumped out of the plane and built the parachute on the way down, which is probably not too dissimilar to how my original business formed. And, I think your point about business plans there, obviously having an idea and a bit of a direction is important. I've developed a fairly extensive business plan for my last business, and we sort of ended up doing almost everything that wasn't on that plan. The whole landscape sort of changed, and it changed so quickly that you sort of have to pivot. So I think, having some understanding of what you're intending to achieve and how you're going to get there is worthwhile, but trying to plan to the nth degree often ends up actually hurting you, because you have to have the flexibility to pivot as you see opportunities or as the business develops. And I think trying to stay too rigid to a plan that's no longer relevant often can be detrimental. Yeah, you're essentially a one-man band. And one of the problems I sort of faced myself, because when I started my tuning shop, I was in that same situation. I kind of got into it because I really enjoyed tuning cars, and that's what I wanted to do. And sort of, a year in, I realized that I was spending about a third of my time tuning cars, and the rest of the time was sort of talking to customers, invoicing, quoting, marketing, all of the rest of the stuff that goes along with running a business. And that stuff I didn't enjoy so much. So how have you found that element? So what amount of your time do you reckon you're actually spending on the tools doing work versus the other elements of being a business owner?
Sadly, I probably feel like it might be that 30% of the time thing, just because as a one-man band, you don't have somebody to take out the garbage, to talk to somebody, to run marketing. Maybe I stopped posting on my Instagram for like probably a year at one point because I just get kind of sucked into it. Yeah, to say how much time I work on the tools, I mean, at a good time, I like to think that it's 70% of the time, but there's other times where it's for sure 30%, because someone wants to do a run of parts, and now you got to call around and get quotes on material. You got to figure out what other parts are needed for the job. You have to call this place because this car came in and it's just got some weird stuff on it that doesn't fit right, that you now have to, instead of going the normal route of like, let me just make this, I'll just make what I need to get where we need to go. But it's like, well, let me make sure that I'm not going to go diving into something that someone's going to look at who provided the parts and they go, oh, the person before you put this on backwards and now it fits. So yeah, you spend a lot of time, sadly, a lot of time doing other things. It's a little difficult. Fortunately, I don't play the marketing game. I'm very word of mouth, and some customers I do spend some time talking with, but I'm at the point where I kind of have a small group of people that I often do the work for, and they kind of bring me something and they go, here, do what you do, make this part. Here's my problem, solve it. I don't care what you do. In that, there is a lot of time of like, okay, again, let me find this material. I guess modeling's a tool. Sometimes let me model this part. Let me figure this out. So yeah, there's a lot of time in that instead of just working on what I like doing. I really like fabricating. I really like making things. So it's difficult when that's kind of, you get pulled away from it to do the other things that actually have to make the business run.
And on that note, is expansion something that you're considering? Would you take on more staff, or are you quite happy with the scale that you're operating at the moment?
I definitely like to take on more staff. I think I mentioned earlier, my friend Garrett, he's been doing a good amount of programming, especially with the new 5-axis that I got. So that's been like a major help, because it allows me to kind of design some weird parts and just throw it at him and be like, here, figure this out. He's way more proficient in Fusion than me. He's actually pulled me into it a lot. So that's been super helpful. I'm really trying to get him on, and then I'd love to have another fabricator. It's really hard to find somebody, especially, I feel like I'm very, very, very particular in what I want. So it might be kind of annoying to have me I've had a friend in who does amazing work and made a part, and it was like, oh, I want it like this. And like, he got it all done. And I just looked at it and I go, yeah, I don't like it. I don't like it. Like, let's do it over. But I do that to myself. I'm not trying to do it and be mean to him or anything, but I do it to myself. I'll make a part. I'll spend all day on it. And if I don't like it, I'll throw it away. It's just, sometimes you can't come back to something, you get too far forward, you try to see something out, and if it's not going, you just start over. That's how I make the parts that I make. I try not to compromise along the way. This is my plan. This is what I want to make. And if it goes well, cool. If I have to make like some of the sheet metal stuff, if I have to make a weird part to get it to fit right, to figure out this bend to get it, and then all of a sudden I'm like a little bit short on the other side, then I go, okay, and that's my template for the next one. Instead of just like, let me weld this little scab on here, and oh, that hole that got drilled offset, like it's fine, you won't see it. Like, if I can weld it shut, I will. if that's that, then it's garbage. I've welded stuff on backwards before and throw it out, start over.
The problem with being a perfectionist.
It's terrible. it's my best and worst attribute. I mean, I've had people, even for myself, just like, oh, just it doesn't have to be really nice. It's like I can't do that.
I always find it frustrating when I spend just an irrational amount of time making something or modifying something that no one else is going to see. Maybe it's hidden under the car or something, but I mean, I know it's there, so I want it to be right.
I try to make parts so that when someone takes it apart, they realize how awesome it is at that point.
Yeah, I think that's something to always strive for. One of the last questions on this particular topic that I've got is along the lines of quoting or estimates for customers. Now, it sounds from what you've said already that you're actually dealing with a fairly tight-knit group of people who probably know your quality of work and the finished product they're going to get, and maybe, I'm hoping, are probably well enough funded that the dollar value within reason is maybe not quite so critical for them. But in general, if you're dealing with just an off-the-street customer and they come in wanting a quote on a job, this is a problem that I face with my old business. It's very, very difficult when you're doing particularly intricate one-off jobs. You've never done it before. How are you going to actually put a dollar value on that and be able to stick to it to the cent? Any insight you can give us there?
I take a good guess for sure based on similar things in the past, but it's still very hard, and probably one of the worst things that I have to, not the worst things, but one of the things that I don't like about the most. But sadly what does happen is I'll make a quote, and the best thing you could do is kind of work to a point. And if you see and feel that it's not going to be trending to the amount of time or cost that you initially talked about, reach back out, tell them, hey, this is going to be a little more. Are you okay with that? Maybe there's some things that, you can change or sacrifice design wise to kind of, I'll say, meet their budgets. I usually don't like to try to meet people's budgets. Just because of the fact that to an extent, it definitely will hinder what I'm going to make them. Mm-hmm. So, I mean, there's a lot of times where, I'll end up eating some time just because it's going to end up a nicer product, a cooler part, and, will warrant, that next person who's going to come in and pay for it. Like I said, sometimes the budget thing, it's real. People have them. I do deal with some people who do have better finances than the average person walking in. That allows me to do something better. But the people that do come in and they want it for cheaper and they go and get the cheaper part, it's a couple times that they do that they'll learn that paying my initial cost, they'll end up there with once they do like the second or third revision of the part from the cheaper person sometimes. So, you do that a couple times, or you let somebody go off and figure that out for themselves. And, they realize like, I'm gonna bring it to you. You're gonna charge me. You're fair. I'm not trying to rob anybody, but time is time, and it's hard to put a value on it. I mean, you could put a value on it, but it's hard for people that want the finished part to pay that money for it, especially when someone wants an exhaust or another mass-produced part. I'm gonna be 3-4 times the cost of whatever that exhaust is, and half the time the material alone costs more than just the exhaust itself.
Yeah.
Because, I mean, that's just the quality of materials that happens.
I think there's a learning curve for the customer if they haven't dealt with high-end fabrication. And again, it's sort of as we've talked about and you just mentioned with that exhaust, their expectations have been grounded in mass-produced parts, and that is just not what you're dealing with. So there's a substantial increase in cost for these high-end custom fabricated parts, and that's just what it is. But of course, the expectations of the customer do need to be kind of matched with your reality as well. Otherwise, all you end up with is a pissed off customer, and they go and jump on the internet and tell everyone how you're a thief, which doesn't help anyone. So it's a balancing act, I think, is probably at the end of the day the best way of describing it. But if you can find that level of customer that has the budget to match what you're going to have to charge them for the work, for a fair amount of work, and you can do the work at the level that you want to be able to do it with. That's the perfect mix for everyone. There's nothing worse than trying to compromise your finished product because you know that the customer doesn't quite have the budget to suit. And at the end of the day, you produce a part that maybe they're not entirely happy with, you're certainly not happy with, and the problem with that is that part's then on the car and other people are going to see it and judge it without knowing that backstory.
Yeah, that's super true. And that's like what I was saying before. Sometimes I just, I end up having to give away time just in order for that to happen, because it's, again, not a great like business plan or anything, but it becomes an investment in yourself. If you end up putting out your best work, even if you're not getting paid for every hour of it, you're going to end up, attracting the clients that can pay for it. If all I do is meet your budget and I put out something a little bit nicer than the guy down the street, there's always somebody who's going to do, air quotes, exactly what I'm going to do for you for much cheaper, a fraction of the cost. You can go and do it, but you're paying me for my time, my experience, my tools, the level of detail that I'm going to put into it, the forethought that I'm going to put into it. Like, how much are you going to like taking this part off later? Because if it's fitted horribly, or you got to take 5 other things off to get it off, or, I end up having, I use a lot of like floating nut plates and, PEM nuts and stuff where you don't have to have another hand wedged behind this panel to take something off. And people always be like, oh, where'd you get that from? It's like, well, I mean, they're easy to find. You just, go get them. Like, oh, how'd you put that? Oh, well, you need this tool. Like, there's a value to it, and not everybody's going to see it from the start. But if you always put it out, you'll get the clients that you really want. And it's not fun. It's not easy, but I think it's a lot of what's gotten me to where I'm at by not compromising, the parts or trying to fit in people's budgets. And maybe the other thing too is, when you go to quote something, just quote it high. If you think you could do it in an hour, you probably should quote 3.
Yeah, I think that's great advice.
And just let them know. I mean, set yourself up for it as well. And
well, then where you quote 3, you think it'll take an hour, you quote 3, it actually takes you 4 hours. You're only losing
an hour
instead of 3.
I mean, yeah, it's definitely difficult. It's one of the harder things for sure, but I think it's important if you want to kind of get to that higher end level and try to make really great, really nice parts. I think that might be part of the investment. I didn't go to college. I didn't get any formal training, and maybe those hours that I lose given away to customers, maybe that's my tuition. I mean,
it's not a bad way of looking at it, actually.
Yeah, but I mean, that's what's gotten me to the clients that I have now, who it's a word of mouth thing. And when you get into that circle of clients, they're going to bring you other people that they've already vouched for. They're kind of the gatekeepers and don't have people coming through who are then going to, start to like nickel and dime you down and ask why everything's so expensive. They just go, oh, this guy's for this guy. I'm on the same level as him. He says he's good. Here, do what you do. Make me nice parts. And it takes a minute to get there, but it's pretty great when you are, because it allows you to do some pretty cool stuff.
Absolutely. All right, JT, let's move towards wrapping this thing up. I think we've taken plenty of your time for today. We've got the same 3 questions that we like to ask all of our guests, and the first of those is, what's next in the future for you?
Probably more machined parts. I guess I'm trying to focus my time on, I hate production, but it can be quite profitable. Instead of just, I'm really capped by the hours that I could put in a day as one person. I can only bill as many hours as I can willingly work. So when you get into production of some parts, it allows you to actually let the machine run while I'm doing something else as well. So trying to get into some production parts probably, and offer some of neater little bits and provide some prototyping parts for people to maybe get into production, or at least proof out so they can go take it elsewhere for production. I've done some product design here and there for a couple people and some other companies where they'll give me something, I'll model it, kind of make their one-offs, and they can go off and test fit and go into production on their own elsewhere. So probably just more machining, I think. Kind of get picky about what fabrication jobs I take in, so I don't have one stream of income, which is just solely fabrication. It'll allow me to be a little more, like I said, picky about what jobs I take on.
Yeah, that makes sense. So I think just what you mentioned there as well is worth just reiterating that, you've got an hourly rate and you've got X number of hours in the week, and that's kind of your ceiling essentially on what you can bring in. So if you can start making parts where you're not just relying on an hourly rate for your wage, that's really going to multiply what you can do. And as you say, you can have that machine running while you're doing something else. So it makes perfect sense. Next question: is there any advice, given your career so far, that you could give to maybe one of our younger listeners looking to pursue a similar career, or even if you could circle back and give advice to a younger version of yourself to help fast track your career? What would that advice be?
I feel like there might not be a fast track to it. I think a lot of it takes time. I've been tinkering with stuff for like 19 years, I think. Let's see, I got my first shop in 2014, summer 2014. So, none of it happens overnight. And, none of my welds looked really awesome the first time, the welder showed up and I got it set up in the garage, and none of my sheet metal stuff was as nice. I mean, it's a long learning curve. There's a lot of great resources out there now that I didn't have, stuff on YouTube and, 3D modeling, all of that's just awesome. There's so many like amazing, like TIG welding tips, and there's all these cups, and people have these trailing gas setups and back purge setup. Like there's all this stuff where I'd have to make my own, like, purging setup, or, machine this block to, use as a heat sink, where now you could just like order stuff. So there's a lot of really great resources for learning and just the products, but I don't know if there's a fast track. I think it's really just a time thing that you have to put in the time. You have to try to make parts, try to make what you want, and you're going to learn something. Even if you go and you do every tutorial and watch every video and they tell you how to do everything, until you try to like cut that piece of metal and sand it well, they don't tell you how to get the feel for, a little like 2-inch sander, disc sander to kind of clean up the edges, and then step down and get it smoother, and hand chamfer some stuff, and just be real meticulous on how your fit up is. Like if you're going to fit some tubing, like if you get a notcher and you notch the tube and you go to put it to a tube, it's going to fit okay, but there's going to be some like really thin burrs and, sharp edges coming off of it. So you got to clean those up, and the mill scale is not going to be cleaned off it. So clean that up. Realize what happens when you weld it when you don't clean up the mill scale. See how different it is when you do clean up the mill scale. I think you just have to put the time in. I don't want to say that there's not a fast track, but I'd probably say don't be afraid to make bad parts.
I think, unfortunately, with the internet these days, budding fabricators look at Instagram accounts like Weld Porn, and they see every second post, or every post is beautiful stacked diamond welds, and get discouraged maybe if that's not what comes off the welder the very first time they use it. And I couldn't agree more. The time on the tools, the practice is really critical. The old story, it takes 10,000 hours to become proficient in anything. And I think these days, sort of a bit of distraction going on, and people sort of want to be an expert the first time they pick up any tool, but that's just not reality. So I think that's a fair point. Get in there, practice, spend the time, understand that you're not going to be great the first time you do anything. Let's be honest, that goes for everything we do. It takes time to learn the skill and get proficient. I mean, even with our courses, we say exactly what you're mentioning there. We'll show you how to do something, be that fabrication or engine building or wiring, but from there you've got to take the skills that we teach you, actually put them into practice, perfect them, and understand them and get that feel for it. And there's no way of fast tracking that particular element of it. That's just putting in time on the tools.
Yeah, Instagram kind of, and all social media sort of, it can be discouraging, but it's also not, it's not real. Every person's weld isn't, there's a guy out there. I promise you that there's somebody out here that every weld that they do is perfect. It's like amazing. But I also guarantee you that if you ask them, they will point out every flaw in that weld, because that's how I am. Every weld that I've ever posted, like, I posted something, my buddy's like, that's amazing. I go, oh, well, you see this part right here? Like, I hate that part. That's the worst part. So, Instagram and social media is pretty great and pretty bad for that, because, not everything's that perfect. Not everything happens overnight. The drag car is going to look like it was overnight because of the fact that I haven't posted anything about it forever. And now, I'm sharing a whole bunch, and it's going to be like, oh, like, when did you do this? And like, I just kind of have like a stack up of pictures, and I'm just kind of sharing it all now. But I mean, that was a pretty long process, and nobody's going to know or realize or care. They're just going to want to see it and then move on to the next thing. So I don't know. Things take time. That's what nobody wants to understand. Things take a long time. It takes a long time to make really nice things. Machining parts. You want a really nice looking machined part. You want those really fine tool paths, those nice step overs with the ball end mill going across it. That might be like 20 minutes, compared to like a bigger step over, like a more scallopy one that, would be a lot faster, but it might not be the appearance that a part you're going for is going to take. And someone's got to either pay or lose money for that time.
Yep, solid advice. All right, JT, last question for today. If people want to follow you, and I certainly urge that they do, where are they best to do so?
Probably just my Instagram. I think that's really where I post things, which is just JTO Power on Instagram. I do technically have jtopower.com, but it's just going to redirect you to my Instagram because I've never built a website. So you could check one of those two places, and hopefully the smart move would be once start probably making some parts to actually get like a website to push some products on. Just kind of weird little trinkets that I've been making across this whole time that maybe other people would be interested in actually having, but I should figure out how to mass produce a little bit of.
All right. Well, we'll link to your account anyway in the show notes, make it nice and easy for people to find you. Look, JT, it's been great chatting. Really interesting to get some insight on everything you do, in particular your business. And we certainly wish you all the success for the future, whatever that may bring.
Thanks so much. I really appreciate you guys having me on. Didn't think I'd be on here, so it's pretty cool.
No problem. It's been great. Thanks. If you enjoyed this episode of Tuned In with JT, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to T.S. DeLosa, hope I've got that right, who has said, if you tune cars, you need to subscribe. Excellent podcast that's always packed full of the best people in this industry. If you're into tuning cars, this is packed full of enjoyable knowledge. Well, thanks for your kind words there. Get in touch with your t-shirt size and shipping details, and we'll fire a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.